So, welcome back everyone, and now, as I promised, we are going to learn about hardware control and control unit. So, what is the hardware control? In this organization, sometime I spell to write it correctly. Control logic is implemented, is implemented. So, in this organization, control logic is implemented with what? That's what I asked myself once, that what it is. Then I just read few more lines and I got it what. So that is by using the logic gates, the flip-flops that we have studied in the detailed manner. We have decoder and etc. But surely there are more things in the digital circuit. So it is having advantage that it can be used fast mode operation. Its advantage is fast mode operation. It can do the things fastly. Hmm, that is the advantage indeed. So RIS is fast one. I didn't mention it there, but RIS is fast one. If you're a fan of the CIC, you might counter with me, but that is completely okay. That's how we develop. And let me also explain something that is called as micro-programmed organization. Micro-programmed, micro-programmed organization. As we are learning about the organization, so let's why to leave any organization. Micro-programmed organization. Um, in this organization, we have the control information, the control information which is stored in control memory. In control memory, the control memory is programmed to initiate. It is programmed to initiate required micro operations. Micro operations. Okay. So micro-programmed organization, as the name suggests, it's micro, it's small program organization. And this we have control information which is getting stored in control memory and initiate required micro operation that is gonna require, like we require to increment, or we require to decrement, or we require to add, we require to subtract, we require to run a loop, and in all that such kind of things. So what is actually working? The micro programmed organization is working. Well, now it's about the control unit. So in the control unit, what we have, it is used it is used for generating generating various control control signals for for operations, that what is going on or what it has to do. So the control unit is doing all that thing sitting inside the CPU. Now we are studying everything inside the CPU. So this is the way we are learning through these all the things. Now, with all that said, let's proceed to the next level of abstraction, which is interrupts. But I'm not going to interrupt you anyway, but we are going to learn about the interrupts in the detailed way. So let's learn about the interrupts. So interrupts are defined. Let me refine it here. So let's define our interrupts. basic thing first, then we will proceed to the levels of the external, internal, and software. Well, interrupts are defined as a set. Let me change the color. As a set of instructions break that breaks the normal execution. The normal execution. Well, I am very much sure that if you are belonging to just a 1 decade old person, now these days kids maybe know that, I don't know about that, but I can talk about 1 decade ago. When it happened that you are working and working, your windows are downloading. Let's say you are downloading your windows, new windows. Let me write it clearly. Windows, Windows XP. Let's say XP version. We are old, right? Okay. So yes, my dear oldie friend. So we have installed, and it shows 98%, 99% after some time, and then something happened. It stops, and after a moment, you just see that it is starting again from 1%. That is the most frustrating thing that we have faced, right? So this is the thing. Well, by downloading the apps, no one ever is having this kind of problem. But if you have downloaded the Windows or something very big, it starts several times because of some interrupts. Sometime it happens. Well, I am not saying that Windows XP always acts like that. I have worked on it too much, my father worked on it too much, and the world worked on it too much. So it was a great operating system. But what I am trying to present you is that interrupts are coming in the format of the normal execution and breaks the thing. Like if your internet connection is break, it starts again. So that is the kind of the frustration which is called as interrupt. So now let's study about the various kind of the interrupts that we have. So let's first study about the external interrupt. As the name suggests that it occurs externally, so it particularly means it is coming from input output devices, like the wire is loose or something like that, from timing device timing device, from power supply. Well, I when I was a kid, I was wondering one day that my CRT TV, cathode ray tube TV, yes, I still use that and I love it. I don't know you are a fan of it or not, but I am fan of it because it's my childhood memory. That's simple. That's why. Okay, so my CRT TV, when the light cuts off, it gets off. That is kind of the interrupt that comes from external power supply. But the thing that I have observed is that sometimes when light cuts up and comes back, when electricity goes out, or you can say black out, in some countries we used to say blackout, when it goes blackout, but that blackout was very minutest time. In that case, if my CRT TV is not that sensitive, it keeps on running. I can notice that because my bulbs, my LED bulbs fluctuate a little, but my TVs keep on running. I am very happy about that. Well, anyone will. Now let's study about the internal interrupt. Well, there are the internal problems also. So internal interrupts. In the internal interrupts, we are going to see that this interrupt is arising illegal from illegal use of instruction or or data. Internal interrupts are also called as traps. Well, these are also called as traps. And examples of it is, well, let me also present the example of the internal interrupt, because the external interrupt depends upon so many things. As the input output device is actually the thing, and the key point here is definitely having the power failure. Mostly the power failure is the reason, or the breaking of any device, losing connection and all that, is the reason of the external interrupt. But in the internal interrupt, these are not the factors. So the example of the internal interrupt are stack overflow, stack overflow, and divide by 0. Well, that's a math problem. Only a mathematician can solve it. A math student can solve it. Um, that is kind of the invalid operation, invalid opcode I would try to write. Well, if you have used the calculator and you write something like 3 divided by 0, so what it shows? Error, because it do not know how to divide it. I once wrote 0 divided by 0. Same result, error. But those of you who have learned the calculus, we all know that it can be solved in most of the cases. It can be solved. So technically, this is the first moment when I studied the calculus, I felt like I am smarter than the machines. So I am smart. Well, I am means you are all smart. Why? Well, very easy. I am teaching you. So you are more smart to grasp all that knowledge that I am going to give you. And I am presenting you continuously. So this is about the internal interrupt. So it's coming from the illegal use of the instruction on data traps. Like once I was a curious child, so once what I did is actually a little bit funny. I gone to my C drive on my computer and I deleted it. So I deleted it. In simple words, I deleted my operating system. And I was expecting everything to run after that. Well, that age, I was just 10 or 11. I was thinking that what will happen if I delete my operating system? Will my PC work? And I actually deleted my operating system. Well, my PC worked. You know why? Because we again installed the Windows. Well, I was using the window. I did not know about the Linux at that time. Maybe I have downloaded that one too, but okay, that is fine. So I deleted the C drive itself. So that is kind of the illegal operation. It should not allow me to do so, but I did that. Okay. So let's begin with the final interrupt, which is our software interrupt. So how the software interrupts actually come? So software interrupts. Well, can you guess, my dear friend, that why the software interrupt comes? Well, external and internal. External plus internal interrupts are basically hardware interrupts. It's basically hardware interrupt, as one is the a power supply problem and other is the illegal thing, the illegal operation that you may apply. But what is the software interrupt? As is generated due to some hardware, but software interrupt, as the name itself is software. When interrupt occurs, state of CPU is pushed into memory stack and beginning address of service routine is transferred to the interrupt until the end of instruction before the fetch phase of next instruction, that is called as software interrupt. I know what you're thinking, that I have not written it, I am not explaining it, I am just speaking out from my mind anything. Well, what is that, Om? That is unfair. You are just speaking and we I don't know even that what you are speaking. You are just not telling us anything. So just tell us so that we can understand that what is you are talking about. Okay, so let me simplify it for you. So software interrupts are basically occurring on the software, obviously, and why the kind of the interrupt actually appears. Well, the reason of appearing it is just in one line, that let's say that we have stack and we have equation x plus y is equal to 5, and the x itself is 3k and k is equal to 1. So I have written three instructions here, and let's say I try to solve the value of y's value. So if I try to solve the y's value first, what's gonna happen? Well, it becomes impossible to solve it because I don't know the value of x, I don't know the value of k. And if I directly jump on the third instruction, so if I go one after another, I can surely figure out the value of y. But if I directly jump on the instruction 3, that the thing is known as software interrupt. Now I think you know that already. So that is the execution problem, you can say. That is the execution line problem. So that's all about the software interrupt. And with that said, we are done with the CPU part. So congratulations, my dear friend. We have traveled a very long journey in the CPU and we have gone through a lot of the interesting things. Like we started from here and we are done with the CPU. So congratulations, my dear friend. In the next one, we are going to start with the instruction pipelining. So till that time, take care, God bless, see ya, and keep smiling.